Hey everybody, welcome back to part 2 of this lecture on 7.2, graphing quadratic equations in standard form. So again, I told you in the last video this little dirty secret of finding the x-coordinate of the vertex. If the equation of a parabola is already in vertex form, you can read off the vertex. If it's in standard form, then the x-coordinate for the vertex is just negative b over 2a, right? And then you plug this number into x, and you get the y-coordinate of the vertex like that. You can do that in all of these, except in one of the few examples where they just give you two points opposite each other. Then you take the midpoint, and that's about all you can do. But for all the other examples, we can use this formula here. The x-coordinate of the vertex is negative b over 2a. So we did number 2 before. Let's look at number 3. Here we have the vertex is negative 5. It's y equals 5x squared plus 10x minus 2. I suggest you pause the video for a moment, find what a, b, and c is, and then go from there. So you can pause it. And if you've done that, hopefully you've come that a is 5, b is 10, and c is negative 2. Negative b over 2a then is negative 10 over 2 times 5, and this is negative 10 over 10, so that's negative 1. So that's the x-coordinate, and then we plug negative 1 in here, and we get or 5 times negative 1 squared plus 10 times negative 1 minus 2 is 5 minus 10 minus 2. That's 5 minus 12, which is negative 7. So the vertex is negative 1, negative 7. And if you wanted to graph this, well, let's see, negative 1, here's negative 1, negative 7. So that's down here. Okay, and we know the graph comes up. It actually hits the y-intercept will be at negative 2. So you have these 2 points like that. And again, right now we don't, here we are, negative 1, negative 7, and here's negative 2. So right now we don't know the time, the x-coordinates are not, for the x-intercepts are not very easy in this example. But we can do it. We have a way of finding that a little later in another lesson. Okay, let's look at example 4. Once again, I will let you work on this. I'll let you pause the video. Okay, and hopefully it came up that a is negative 1, b is 4, c is 21. Negative b over 2a turns out to be positive 2, and plugging that 2 in here. Just remember this minus sign here doesn't apply. You're not changing the sign of x, you're changing the sign of x squared. So this is you're not squaring negative 2, you're squaring 2 and then multiplying it by negative 1. So you get negative 4 plus 8 plus 21, which is 25, and so the vertex is 225. Now in this case, you can actually find the x-intercepts because they're kind of nice if you're good at factoring. If you find the x-intercept, you set this equal to 0. And you can sort of see that maybe you can factor this. I'm going to change the minus sign, multiply both sides by negative 1. So negative 0 is just 0, and we get x squared minus 4x minus 21. And this actually factors as x minus 7 times x plus 3. So x is equal to 7 and negative 3. Those are our intercepts, our x-intercepts. Okay. And you can see that if you take the midpoint of these, the midpoint 7 plus negative 3, that's 4. 4 divided by 2 is 2. So we get the same x coordinate for the vertex, and this is going to be our x-intercepts. Okay, there's 2, it's way up here, 225, and we know it opens down because that A is negative, right? Okay, I didn't draw this to scale, obviously. 25, you know, 25 is way up here, but just so I could fit it all on one page. All right, now this one last example is kind of interesting. This is a geometry problem. We want to find the dimensions of the largest rectangle with a perimeter of 120 feet. Okay, and I remind you the perimeter is, if W is the width and L is the length of the rectangle, then the perimeter is 2W plus 2L. And the area is length times width, or in this case, width times length. The order doesn't matter. And what you want to do is you're trying to find a W and L so to maximize this, given that the perimeter is 120. So you're given that 120 is 2, I'm just going to, well, 2W plus 2L. And what happens is it would be great if we could write A just in terms of one variable, and we can do that by writing W in terms of L. We can first divide everything by 2, and we get 60 equals W plus L. Subtract L from both sides. Get 60 minus L equals W. And then A becomes W times 60 minus L. All right. Now, this might not look like a quadratic function at first because there's no x, and there's also, oh, I try again, Mr. Blackford. Okay. Equals W times, right, A equals 60 minus L times L. Okay, put everything in terms of L. All right. Now, this actually is a quadratic function because you can distribute the L and you get 60L minus L squared, which is the same thing as minus L squared plus 60L. This is almost a quadratic function, and so you just have an L instead of an X, right? So L is, so if you replace L with X, you get minus X squared plus 60X plus 0. So it's a quadratic function. It's just a quadratic function in L. And in this case, A would be -1, B would be 60, and C would be 0. All right. Well, what are we going to? We're trying to find the maximum area. And what this shows is if we were to graph this on the AL plane. Okay, we don't see many AL planes, but here we also know that A is 0 and L is 0 or 60. So the graph would look like this. Where do we get the 60 from here? Because we can see the area will be 0 and either this factor is 0 or this factor is 0. Okay, so if 60 minus L is 0, then L has to be 60. We know this parabola opens down because A is negative. And we can find that we can either take the midpoint between 0 and 60 and find that this is 30. Or we can say minus B over 2A is negative 60 over 2 times -1. So this is 30. Okay. But here we can see that the vertex occurs at 30. So and that's the largest area. The the L coordinate tells us the length that we need, and then the A coordinate of this point is the actual area. So we get the maximum area when L is 30, W is 60 minus 30, which is 30, and the maximum area will be 30 times 30 times, which is 900 square feet. Okay, and that's why you can change the other numbers, but it turns out that what the maximum, if you have a rectangle, to maximize the area, that rectangle is actually a square. Okay, if you fix a perimeter, then the largest rectangle must be a square, and that will always happen. All right, so work on the problems, do the homework, and I will see you next time.